Next, we need to talk about parallel and perpendicular slopes so that we can use that information when we're writing more equations. We have a pair of parallel lines here. Notice that they go in the same direction forever and ever. They won't ever touch. Please notice that your slopes are both positive here. And not only are they both positive, but their slopes are going up and over at the same rate. And it keeps going up and over at the same rate on both lines, which means that they will never, ever, ever intersect. The slope that's going up and over at the same rate tells us that our slopes are equal. But when you look at the perpendicular slope, notice that your perpendicular slope here on the red line and this blue line right here, they intersect at a 90-degree angle. Well, this blue line has a positive slope, where the red line has a negative slope. So clearly they can't be equal like parallel slopes. Parallel slopes are always equal. Perpendicular slopes are clearly opposite. One's positive and the other one's negative. So already I know that perpendicular slopes are opposite. Now there's more to that. Okay, we're going to fill that in just a minute. Because it's not just that they're opposite, but they're going at a different rate. This blue slope has a rise and a long run. This red slope, if I start here, has a long negative run and a short rise. And in fact, these are opposite and what we call reciprocal. Because the rise on the blue slope is the same as the distance of the run on the negative slope. The run on the blue slope turns out to be the same as the distance of the rise of the negative slope. So these are opposite reciprocal. So what does that mean? Well, if my first slope, let's say, is a over b, a fraction, is perpendicular slope, and this right here is the shorthand symbol for perpendicular, the perpendicular slope would be opposite, meaning positive versus negative, and reciprocal, meaning the numerator ends up in the denominator and the denominator ends up in the numerator. So the opposite reciprocal slope would be negative b over a. So let's just take a look at some slopes and finding their perpendicular slopes. Let's say I give you a slope of 2/3. What is its perpendicular slope? Well, opposite meaning if it's positive, then my perpendicular slope automatically has to be negative. And reciprocal meaning instead of 2/3, I have 3/2. What if I give you a slope of negative 1/4? Well, the opposite of negative is positive. The reciprocal of 1/4 is 4 over 1. But no one really writes 4 over 1. We usually just write 4. Which brings me to my last example. What if I give you a slope of a whole number, like 8? Notice this isn't a fraction, but you can think about it as a fraction by putting it over 1. So is opposite reciprocal? Positive 8's opposite sign is negative. The reciprocal of 8 is 1 over 8. So here's a few examples of opposite reciprocals, and we're going to need to be able to do that quickly in order to find the perpendicular and parallel lines. So next is the steps for writing equations using perpendicular and parallel lines. Step 1 says to put the given equation into slope-intercept form. And we do that in order to find the slope of the parallel line or the perpendicular line, whichever is given. If the lines are parallel, then I know the slope of my new line is going to be the same. Although if the lines are perpendicular, then the slope of the new line is opposite reciprocal of the given slope. Now that I have new information, I want to plug this new slope and our given point into point-slope form and finish the equation like we did earlier. Solve for y to get it in slope-intercept form. Our first problem asks us to find the equation of a line passing through -2, -7 and parallel to the line 10x plus 2y equals 7. Well, my point will be my x1, y1, so I already have half the information I need. The only other information I don't have is my slope. So in order to find my slope, I need to use the line and find a parallel slope to this line. Well, I can't figure out what the slope of the line is until I solve for y and put it in slope-intercept form. So to solve for y, I'm going to move the 10x to the other side of the equation to get 2y equals -10x plus 7. Then I'm going to divide by every term by 2 to get y equals -5x plus 7 halves. From this equation, can you tell me what the slope is? Well, sure, my slope is -5 of the given equation 10x plus 2y equals 7. But that's not what I really care about. What I'd like to know is what is the parallel, and when you have two lines slashed like that, that is a shorthand for parallel. So what is the parallel slope? My parallel slope will also then be 5, because if the lines are parallel, then the slope of the new line is the same. So now I have a slope of -5. I have an x1, y1 of -2, -7, and now I can just use my point slope form, just like I did on the earlier problems, to find my equation. Y minus y1, which is -7. Notice there's a minus from the equation. There's also a negative from the 7, which makes it a minus and negative, equals m, which is -5, parentheses x minus x1, and my x1 is -2. Notice there's a negative because the equation has a minus in it, and a negative because the 2 is negative. Cleaning this up a little bit, minus a negative is really adding a positive, so I have y plus 7 equals distribute -5. Again, we have minus a -2. Minus a negative is really plus a positive 2. So when I distribute my -5 to multiply to my positive 2, I'm left with -10. And to solve for y, I'm trying to get y all by itself, I'd like to subtract 7 from both sides to get my final equation of y equals -5x minus 17. This equation is going to be parallel to the line 10x plus 2y equals 7, and it's also going to contain the point -2, -7. On the next problem, I'd like to find the equation of a line passing through this point, -4, 2, which is my x1, y1. And this time I need to be perpendicular to the line y equals 1/3 x plus 7. Again, like in my first problem, I need to find the slope, and I need to find an x1, y1. Well, I clearly already have my x1, y1, -4, 2. What I need to find is my slope. Looking at the information given, I need to be perpendicular to this line. Notice that this equation, unlike the first example, is already solved for y. So this is in slope-intercept form, and I can clearly tell that this is my slope right here. So the slope of my given line is 1/3. But remember, I don't care about the given line. What I want to be is I want to be perpendicular to the given line. And this is the symbol for perpendicular. So what is the perpendicular slope to positive 1/3? Well, perpendicular slopes are opposite reciprocal. If 1/3 is positive, then my perpendicular slope has to be negative. Reciprocal of 1/3 is 3/1. Clean that up to be just -3. So I believe my slope of my line perpendicular is going to be m equals -3. Now that I have this information, I can finish my problem by substituting the information into the point slope form. Y minus y1, which happens to be 2, equals m, now I have my m of 3, times the quantity x minus x1, which is a negative 4. Notice there's a minus because the equation has a minus in it, and a negative from the negative 4. And minusing a negative really means adding a positive. Some of you might just go ahead and write down x plus 4, and that's fine. Distributing, I get y minus 2 equals negative 3x. Negative 3 times a positive 4 is negative 12. To solve for y, I'd like to add 2 to both sides. And my final answer is y equals negative 3x minus 10, which is the equation of a line which passes through the point negative 4, 2, but it's also perpendicular to the line given y equals 1/3 x plus 7. This is my final answer. We do have a few special cases using perpendicular and parallel. I have 4 very quick examples here. Notice I didn't put a lot of room here because they don't take a lot of work. So the first problem says find an equation passing through this point. That's going to be my x1, y1. And I need to be perpendicular to this line x equals negative 4. Notice that my x equals negative 4 doesn't have a y value in it at all, which means it's one of my special cases. In this case, I have x equal to, so that tells me I have a vertical line. So my question is, what's perpendicular to a vertical line? Well, a horizontal line is perpendicular to a vertical line. So my equation has to be a horizontal line. Well, how am I going to figure out what a horizontal line is? Well, I'm going to use my HOI. Horizontal lines have 0 slopes, and their equations look like y equals some number. So I have y equals, and which number am I going to choose? 6. That's the solution. Notice there's no work. It's a very easy problem, but it's also very easy to mess up. So be careful when you're looking at your perpendiculars and your parallels with your verticals and your horizontals. The next problem says find an equation passing through the point 4, 8. Again, that's my x1, y1. This problem is also perpendicular, but it's perpendicular to y equals 9. Well, what does y equals a number look like? Y equals 9 is a horizontal line because my HOI says horizontal lines have 0 slopes and look like y equals a number. So I know y equals 9 is a horizontal line. What's perpendicular to a horizontal line? Well, a vertical line. So I need a vertical line that goes through 4, 8. How do we write vertical lines? Vertical lines are written x equals some number. That's what the VUX says. So x equals some number. Which number am I going to choose out of my points 4 and 8? Well, I will choose the x value, or 4. The next problem says find an equation passing through negative 1, 5, yet this time I'm parallel to x equals 3. Parallel. So we have x equals 3, and my HOI VUX tells me that VUX x equals is a vertical line. So I need to be parallel to a vertical. What kind of line is parallel to a vertical? Well, another vertical is parallel to a vertical line. So my equation is x equals some number. Which number am I going to use? Well, I'm only given 2 numbers. I need to find a vertical line passing through these points. So that's going to be x equals the x-coordinate, or negative 1. The last problem I have, find an equation passing through this point x1, y1, and this time I need to be parallel to y equals negative 7. Y equals is a HOI problem because horizontal lines have 0 slopes and they look like y equals a number. Because this looks like y equals a number, I have a horizontal line. What's parallel to a horizontal line? Another horizontal line. So I'm trying to look for an equation of a horizontal line that passes through 11, negative 3. Well, a horizontal line, HOI, says I start with y equals in my equation. Horizontal lines like y equals a number. And what is my y value? Well, in this case, -3. Notice that none of these were all that spectacularly hard, but because they're kind of easy and they're not showing much work, it's also easy to mess it up. Let's take a look at some rules of thumb here. When I'm perpendicular, what happened to my letter here? Well, my equation started out to be x equals, but my answer turned out to be y equals. Because x equals is a vertical line, y equals is a horizontal line. Notice my letter changed. Whereas on the parallel problems, my letter was x and it stayed x. My letter was y and it stayed y. Because parallel lines have the same equation, either x equals or y equals. So that's one little rule of thumb that you can use. And then you're always choosing the point from your ordered pair that you're given, using the letter that you've chosen.